Hi everybody, welcome back to Algebra. We are going to go ahead and get started on our next lesson, which is evaluating expressions. Fun stuff! As I try to get this open. Alright, cool. So this is a lot of vocab, note-taking kind of stuff, not as many try on your owns. But let's go ahead and get started. So, vocabs. If you need to, pause the video. Otherwise, I'm just going to kind of power through to make the video shorter. But you can pause it and just write it at your own pace. So, some of these words we already know, but a variable is a letter that we represent a value with. So we'll put in a letter instead of a value because maybe that value is something we don't know or it changes a lot. Hence why we call it a variable. So the most common one you're going to see is x. Now, a coefficient is a number being multiplied with the variable, so it's usually the number right in front of the variable. For example, 3x, 3 right here is our coefficient, okay, because it's a number with the variable. Our constant is a number by itself, so it isn't influenced by a variable at all. It might be added or subtracted with it, but it doesn't have a variable within its own self. So -7 is by itself, it's a constant. A term is the part of the expressions that are separated by addition signs. So, for example, if we put all of it together, 3x is a term because it's all one thing, and 7 is a term because it's one thing. And the only thing that separates it is this addition sign. Sometimes if you see a subtraction sign in there, remember subtraction is really just adding a negative. So when we say subtraction, like if it said 3x minus 7, it really means we have 3x and -7 as our terms. Because we can replace this minus sign with a plus, a negative sign. So it would make a little bit more sense. I'll show you in class. An expression is a mathematical sentence. We already did it. So 3x plus 7. A single variable by itself can be an expression. A single number by itself can be an expression. It's just math. An equation is two expressions that we set equal to each other. So the only difference between an expression and an equation is that the equation has an equal sign. Simplify, we already talked about, is to perform operations to get a single value. So when we do 3 plus 5, when we get 8, we simplified it. Evaluate is to substitute in a value for a variable and then to simplify it. So if we have x plus 4, but we know x equals 6, we can do 6 plus 4 and we know the whole thing equals 10. Okay? Now a numeric expression has only numbers. We talked about that last class. An algebraic expression has numbers and variables. Okay, so it has to have a variable in order to be algebraic. When we simplify numeric expressions, we did this. We do GEMDAS, which is grouping, exponents, if I can click it, multiply, divide from left to right, add, subtract from left to right. Some of the stuff we've already done. Now, to evaluate an algebraic expression, 2 steps. 1, replace the variable with a specific value. So when we replace it, we're substituting it in. And we always use parentheses when we do that. Okay? And then simplify the resulting expression using the order of operations. So 2 quick steps. The key word there is to substitute. Okay? So we want to plug stuff in and then simplify. Alright? So example 1. Evaluate 2ab plus 3ab when a equals 5 and b equals 3. Now when there's no operation happening within the terms, you can automatically assume it's being multiplied. So this is really 2 times a times b and 3 times a times b. So step 1, we're going to plug in 5 for all the a's and 3 for the b's. And when we plug it in, we're putting the 5 and the 3 in parentheses. So we know that they're separated. This is what a is and this is what b is. Okay? This is a, this is b, a, b. Okay? Now, for step 2, we're just going to go ahead and simplify because all it is numbers now. So I'm going to do my multiplication first. I'm going to do 2 times 5 over here. I'm going to do 3 times 5. Well, I'm going to do 2 times 5 first. I get 10. Then I can do 10 times 3 gives me 30. Now I can go to this side. 3 times 5 gives me 15. 15 times 3 will give me 45. And I can finish off the addition. And I get 75 for my answer. So all I'm doing is plugging it in and chugging it out. That's what you're going to hear me say plug and chug a lot. Which means plug in and work it out. Okay, so you guys get to try this one on your own. Please show all the steps to it, because that way when we go over it, you can see where your steps match and where they don't. Okay? Alright, so next one, I think you guys have this one. I hope you have this one. Should probably pull out the homework and make sure it's next to me too. Oh, this one, you're doing both of these on your own. Just kidding. This one you're doing on your own. Sorry. But this one's a little bit easier because it's only one variable you're plugging in. So try that one on your own as well. Alright, now absolute value. You'll see this pop up a lot because this is what makes it into algebra. Like this, it's a higher level thing, so that's why it's okay in algebra. The symbols are just two straight lines, okay? They're very, very similar to a 1, so please make that distinction. At least make the absolute value line longer so it doesn't look like a 1, okay? We call it an absolute value. The absolute value just tells the distance something is from 0 on the number line. Now, because it's telling us a distance, the absolute value is always positive, okay? So, just be aware that when you're plugging things in, alright, remember they act as a grouping symbol when you have an operation in there. So, example 2, given x equals 1/2 and y equals -3, evaluate the expression. So, step 1, I'm going to plug in -3 for the y. This is why I'm putting it in parentheses, because if I didn't have parentheses, it would look like -3 minus 3. So please make sure it's in parentheses. And there was no x, so it didn't matter. That's why it was easy. So now I'm just going to go ahead and simplify. I'm going to work on the grouping symbols first. So -3 times -3. I just said this stuff. So -3 times -3 gives me a positive 9. 9 plus 7 will give me a 16. Once I have a single number in there, I can take the absolute value. So when I say, what's the absolute value of 16? How many spaces away from 0 is 16? 16 places. So the absolute value of 16 is 16. 16 plus 2, 18. That's all I'm doing. Okay? You guys are trying these two on your own. There are x's in these two, no y's. Okay? But it's okay, because even though x is a fraction, it'll go away. I made it very nice for you. So go ahead and give those two a try. When you are done, go ahead and replay the video. Okay, moving on to squares, square roots, and cube roots. So, really quick, a radical is this, okay? This symbol is a radical. Alright, when it doesn't have a number in here, it's just a square root. Alright, which just means what number times itself gives that radicand. Radicand is the number under the radical. Ooh, sorry, I have a meeting. Then the next one has a little number in it with a 3. So when it has a 3, it's called a cube root. And it just asks what number times itself 3 times gives that radicand. When you have a little 2 on the outside of a number, that means squared. So you just multiply a number by itself 2 times. And with a 3, it's cubed. You multiply it by itself 3 times. Okay? You should know how to find all the perfect squares and perfect cubes from 1 through 10. So if the root is 1, perfect square is 1, and the cube is 1, because I just multiplied 1 times 1 gives me 1. 1 times 1 times 1 gives me 1. 2 times 2 gives me 4. 2 times 2 times 2, 3 times, gives me 8. 3 times 3 is 9. 3 times 3 times 3 is 27. And you just keep going like that until you fill it in. So these should be memorized. However, if you don't, it's not the end of the world because you do have access to a calculator. It's just going to save you time if you have it memorized. So I would strongly suggest, the square roots, the perfect squares, should be memorized by now. The perfect cubes, if I had to, I could memorize them. But, I know 1 through 5 for sure. So, that's that stuff. Example 3. What is the value of expression when a is 64 and b is -5? So you're plugging it in here. Okay. This little 3 is hanging out with the radical, not with that -2. There will be a clear distinction between the 3 when it's on -2 and when it's on a radical. If it's tucked into this little elbow, like it is now, it's part of the radical. Okay. So step 1, I'm going to go ahead and plug the stuff in. So I plug in what A is, and I plug in what B is. And then I'm going to go ahead, because there's an operation here, I'm going to simplify this. radicals. This is where the radical is a grouping symbol. So simplify it to negative 5 squared gives me 25. It changes to a positive 25. Okay, then I go ahead and add these two together. I get 89. The cube root of 89 is actually not a nice number because 89 is not a perfect cube. So you can go ahead and write it as a decimal. So that comes out to 4.5-ish. So then I just go ahead and multiply negative 2 times 4.5 gives me negative 9. That's an estimation. It's not the greatest example. This would have been better if it was like 125, which it should have been. Because then it would have looked like a lot nicer. But it works out for your examples. So go ahead and try these two on your own. They're really quick. And that's it for the video. Okay, we will go over all of these try on your owns next class. And we'll do an activity as well. Other than that, I'll see you guys later. Oh, wait, I'm going to say that, but then I can't because I have to stop the video. Okay, see y'all later. Bye.